Hi, I am Dr. Harikrishna Mulam, Associate Professor, Department of EIE, VNR VIGNANA JYOTHI. In this lecture, let us see one more problem related to time response analysis. Please play the video at 1.x or 2x speed to save some time. Here they are saying that there is a positional control system with velocity feedback which is shown in figure. So whatever the positional control system they are mentioning about is this system, and this positional control system has a open loop transfer function g of s is equal to 100 by s into s plus 2, whereas feedback transfer function h of s is equal to 0.1 s plus 1. For such a positional control system, what is that we need to do? We need to find the response of the system for unit step input. Therefore, we need to find the response C of t of the system when the input R of t is unit step input, which is mathematically represented as 1. So, as we already said, this type of system has a open loop transfer function of g of s is equal to 100 by s into s plus 2, whereas feedback transfer function h of s is equal to 0.1 times s plus 1. First of all, let us find the closed loop transfer function of the system. The closed loop transfer function of this system is equal to, the formula is g of s by 1 plus g of s h of s. That is equal to g of s is 100 by s into s plus 2. Okay, so which can be written as s square plus 2s divided by 1 plus g of s. Therefore, 100 by s square plus 2s into h of s is 0.1 times s plus 1. If you simplify this, you will get it as the numerator will be 100 and the denominator will be s square plus 2s plus 100 times 0.1s plus 1, which is equal to 100 by s square plus 2s plus 100 into 0.1s is 10s plus 100 into 1 is 100, which is equal to 100 by s square plus 2s plus 10s is 12s plus 100. So this is the closed loop transfer function of this system. And if you see here, in order to understand whether the system, second order system, is undamped system or underdamped system or critically damped system or overdamped system, always compare the transfer function of the system with the standard way of representing a transfer function of a second order system, which is equal to omega n square by s square plus 2 zeta omega ns plus omega n square. So if you compare this denominator term with this denominator term, you can write omega n square is equal to 100. Therefore, omega n is equal to square root of 100, which is equal to 10 radians per second. Similarly, if you compare these two denominator terms, 12s is equal to 2 zeta omega ns. Therefore, 2 zeta omega n is equal to 12. Therefore, zeta is equal to 12 by 2 into omega n, which is equal to 12 by 2 into 10. 2, 6, 12, 6 by 10, it is equal to 0.6. Zeta value is 0.6. That means zeta is in between 0 and 1. Such a system, you call it as underdamped system. If the zeta value is in between 0 and 1, such a system is called as underdamped system. Then we are asked to find the response of the system. The response of the system C of t when the input is unit step input. But based upon the zeta value, we could understand that the system is underdamped system. Therefore, the expression for response of the system of a underdamped second order system when the input is unit step is given by the formula 1 minus e power minus zeta omega n t by square root of 1 minus zeta square into sine omega d t plus theta. So this is the expression for response of second order underdamped system when the input is unit step input. You know zeta value, you know omega n value, and what else we need? Omega d we need. Omega d is the damped frequency of the system, and which is given by the formula omega n square root of 1 minus zeta square. Omega n you got it as 10 radians per second into square root of 1 minus zeta is 0.6. You got 0.6 whole square. That is equal to 10 square root of 1 minus 0.6 whole square is 0.36. That is equal to 10 square root of 0.64, which is equal to 10 square root of 0.64 is 0.8. 0.8 into 10 is 8. So omega d is 8 radians per second. Then let us also try to find a theta value. And we know that theta is given by the expression tan inverse square root of 1 minus zeta square by zeta. That is equal to tan inverse square root of 1 minus zeta square is 0.6 whole square by 0.6. And if you find it, it comes across tan inverse square root of 1 minus 0.6 whole square is 0.8 by 0.6. It comes around 53.123 degrees. But we know that the theta is specified in terms of radians. Therefore, this degrees has to be converted into radians. For that, you need to multiply it with pi by 180 degrees. Therefore, theta will become 0.926 radians. So, theta value is 0.926 radians. Therefore, the response of the system C of t is equal to 1 minus e power minus zeta is 0.6 into omega n is 10 t whole divided by square root of 1 minus zeta is 0.6 whole square sine omega d is 8 radians per second. So 8t plus theta is 0.926 radians. Therefore, this square root of 1 minus 0.6 whole square is 0.8. Its value is 0.8. 1 by 0.8 is 1.25. Therefore, this is 1 minus this 1 by 0.8. This 1 by 0.8 is 1.25 into e power minus 0.6 into 10 is 6t into sine 8t plus 0.926. So this is the response of this positional control system when the input is unit step. In this manner, you need to find the response of the system if the problem is given for maybe 3 marks or 4 marks like that. But if at all it is given as a long answer question, then you need to derive this expression for C of t instead of directly using the formula for C of t. Right? Let us see that part also. We could understand that the transfer function of this closed loop control system is equal to 100 by s square plus 12s plus 100. And we know that transfer function means Laplace transform of output by Laplace transform of input, which is equal to 100 by s square plus 12s plus 100. Therefore, C of s, response of the system, output of the system in S domain can be written as 100 by s square plus 12s plus 100 into R of s. We already told the input R of t is unit step input. Therefore, R of s will be the Laplace transform of R of t, which is equal to 1 by s. But if you see, as zeta is equal to 0.6, we already said that this system is underdamped system. For underdamped systems, the poles of the system will be complex conjugate pair. Complex conjugate pair. Let us prove that also. Poles are complex conjugate. Let us find it. So poles means the roots of this denominator polynomial. It is something like a square plus bs plus c. Therefore, the poles of this system or the roots of this equation is equal to minus b, which is like minus 12, plus or minus square root of b square, which is 12 square is 144, minus 4, a is 1, therefore I am not writing, c is 100 by 2a. 2a is, a is 1 again. Then, therefore, that is equal to minus 12 plus or minus 144 minus 400 is minus 256 by 2. That is equal to minus 12 plus or minus square root of minus 1 is j. Square root of 256 is 16 by 2. Therefore, it comes out as minus 6 plus or minus j8. So, these are the poles of this system or the roots of this characteristic equation, which is s square plus 12s plus 100. So, these poles are complex conjugate pair. Then, why did we discuss all this? The reason is, we got C of s as 100 by s square plus 12s plus 100 into R of s is 1 by s. Therefore, if you want response of the system C of t, you need to take inverse Laplace transform of this C of s. But we don't have any direct formula for this type of expression in Laplace domain. Inverse Laplace transform formula is not there for this type of expression. Therefore, before finding the inverse Laplace transform of the expression, maybe you need to get the partial fractions of this expression. Therefore, C of s is equal to, you need to write the partial fractions for this expression. How to write the partial fractions for this expression? Okay, one root is s is equal to 0. Whereas the remaining two roots of this expression are complex conjugate pair poles, minus 6 plus or minus j8. Therefore, the expression should be written as a by s plus bs plus c divided by s square plus 12s plus 100. Let us find these residue values, a, b, c residue values. So, a is given by c of s into the term related to a is s, and the root corresponding to s term is s is equal to 0. Therefore, c of s is 100 by s square plus 12s plus 100 into 1 by s into this s, yes, when s is equal to 0. This s gets cancelled, and if you substitute s is equal to 0, this will become 0, this will become 0, 100 by 100, it will be 1. The value of a is equal to 1. Now let us try to find b and c as well. So here c of s is equal to, what is c of s? 100 by s square plus 12s plus 100 into 1 by s is equal to a by s. Now a is 1. 1 by s plus bs plus c divided by s square plus 12s plus 100. Take the LCM and find this expression. So it is s square plus 12s plus 100 into s, and in the numerator it will be s square plus 12s plus 100 plus bs plus c into s, that is bs square plus cs. And this is the expression on the right hand side, and left hand side it is equal to 100 by s square plus 12s plus 100 into 1 by s. Now if you compare the numerator on the left hand side with the numerator on the right hand side, you will get the values for b and c. So you see here, is there any term on the left hand side related to s square? No. Therefore, the coefficient of s square on the left hand side numerator is 0, is equal to, compare with the coefficient of s square on the right hand side. So here this s square is there, its coefficient is 1. And here another s square term is there, its coefficient is b. Therefore, the total coefficient of s square is 1 plus b. Therefore, we will get it as b is equal to minus 1. b is equal to minus 1. Similarly, compare the coefficient of s power 1 on left hand side with the coefficient of s power 1 on right hand side. There is no s power 1 term on the left hand side, therefore its coefficient is 0, is equal to the coefficient of s power 1 on right hand side is 12s plus 6s, cs, therefore it is 12 plus c. Therefore, c is equal to minus 12. c is equal to minus 12. Like this, you need to find residues a, b, c in order to get the partial fraction for the c of s expression. Let us proceed further. Therefore, the partial fraction expression for c of s is equal to a by s, where a is 1, 1 by s, plus bs, b value we got it as minus 1, so minus 1s, plus c, c value we got it as minus 12, divided by s square plus 12s plus 100. Therefore, if you take this minus common and out, it will be 1 by s minus s plus 12 by s square plus 12s plus 100. Okay. So for this expression, you need to find the inverse Laplace transform. But we know that inverse Laplace transform of 1 by s is equal to 1. But for this s plus 12 by s square plus 12s plus 100, there is no direct inverse Laplace transform formula. Therefore, you need to rearrange this expression so that you can use some standard inverse Laplace transform formulas. Okay, so such formulas are, this is inverse Laplace transform of s plus a by s plus a whole square plus omega square is equal to e power minus at cos omega t. Similarly, inverse Laplace transform of omega by s plus a whole square plus omega square is equal to e power minus at sin omega t. So, as there is no direct inverse Laplace transform formula for this expression, I wanted to rearrange this expression in this form so that I can use these formulas. I can use these formulas. Let us see. Therefore, 1 by s minus, so you need to write it in the form of s plus a whole square plus omega square in the denominator. Therefore, if you see, it is s square plus s plus a whole square is s square plus 2as. Therefore, let us write this 12s in the form of 2as. Therefore, 2 into a is 6. Yes. Therefore, a square will be this, as a is 6, a square will be 36. Therefore, let me write in that form. Okay. So, if at all the numerator has s term, it should have something like s plus a. Okay. So, as a is 6 here, even this 12 I would like to write okay, as s plus 6, something like that. So, s plus 12 is written as 6 plus 6 divided by s square plus 2 into 6 into s, as 6 is a, 6 square is 36 plus out of 100, if 36 we have separated, remaining is 64. Therefore, you can write it as 1 by s minus s plus 6 divided by, this is like s square plus 2as plus a square, which can be written as s plus a, where a is 6, s plus 6 whole square plus whatever is left over, 64 is there. That should be written in the form of omega square. Therefore, 8 square, which is equal to 1 by s minus s plus 6. Okay, I am writing up to here. S plus 6 by s plus 6 whole square plus 8 square. What is left over? 6 is there. The plus 6 into minus. So, minus 6 by s plus 6 whole square plus 8 square. This is in the standard form of s plus a by s plus a whole square plus omega square. But this is not in the standard form. Standard form is omega by s plus a whole square plus omega square. So, as per that, this is a, this is omega. Therefore, here, if at all I wanted to use this formula, the numerator should have 8. Okay. Therefore, again you need to adjust. Let us multiply it by 8. As we cannot do like that, divide it by 8. Therefore, C of s is equal to 1 by s minus s plus 6 by s plus 6 whole square plus 8 square minus, okay, this is omega. Therefore, I would like to take it this 6 by 8 out. So, minus 6 by 8 into 8 by s plus 6 whole square plus 8 square. Now, this is in the standard form, this is in the standard form, this is in the standard form. Therefore, you can apply all these formulas, inverse Laplace transform formulas, and get the expression for C of t. Therefore, C of t is equal to inverse Laplace transform of C of s is equal to inverse Laplace transform of 1 by s is 1 minus inverse Laplace transform of s plus 6 by s plus 6 whole square plus 8 square is e power. What is a here? Minus a is 6. Therefore, minus 6t cos 8t minus 6 by 8. And the inverse Laplace transform formula for this is e power minus at sin omega t. That is e power minus a is 6 t sin 8t. And if you take e power minus 6t common, 1 minus e power minus 6t into cos 8t plus 6 by 8 sin 8t. That is equal to 1 minus e power minus 6t into, if I take LCM, it will be, denominator is 8 and here it is 8 cos 8t plus 6 sin 8t. We need to further simplify it so that it appears as per the standard formula that we give for the response of a second order underdamped system. Okay. Now, so let me once again write C of t is equal to 1 minus e power minus 60 into 8 cos 8t plus 6 sin 8t by 8. And before proceeding further, if you remember, when we discussed about the derivation for response of second order underdamped system when the input is unit step input, we have considered this right angle triangle with an angle theta here, and the opposite side is equal to square root of 1 minus zeta square, and the adjacent side is zeta, and hypotenuse is 1. So in this system, as zeta is equal to 0.6, okay, square root of 1 minus zeta square becomes 0.8, whereas zeta, as we already said, it is 0.6. Therefore, you can write sin theta is equal to opposite side is 0.8 by hypotenuse is 1, that is 0.8. Similarly, cos theta can be written as adjacent side by hypotenuse, which is 0.6 by 1, which is 0.6. Therefore, in order to see that your response looks in this standard form, 1 minus e power minus zeta omega n t by square root of 1 minus zeta square into sine omega dt plus theta, you need to make some adjustments. Okay. And this is like sine a plus b, which is equal to sine a cos b plus cos a sin b. Okay. Therefore, if at all this 0.8 is there in the numerator and 0.6 is there in the numerator, you can replace those terms by sin theta and cos theta, and finally you can get something like this. Therefore, 1 minus e power minus 60 into, if at all this 8 has to become 0.8, it should be divided by 10. Therefore, I am dividing this entire expression by 10. Okay. If you divide this entire expression by 10, so, but as you cannot do like that, it should be multiplied by 10 as well. Therefore, the expression will be 8 cos 8t plus 6 sin 8t. And what else is left over? 8 is left over here, and let us bring it out. Let us bring it out. Therefore, this is 1 minus 10 by 8 is 1.125 into e power minus 60 into 8 by 0.8, 8 by 10 is 0.8 cos 8t plus 6 by 10 is 0.6 sin 8t. That is equal to 1 minus 1.125 e power minus 60 into, let me write this first, sin 8t into 0.6. 0.6 is cos theta. So cos theta plus cos 8t into this 0.8 can be written as sin theta. That is equal to 1 minus 1.125 e power minus 60 into sin A cos B plus cos A sin B is written as sin A plus B, that is 8t plus theta. But theta value, we have already found it using this formula, tan inverse square root of 1 minus zeta square by zeta, which has come around 0.926 radians. 0.926 radians. Therefore, finally, the expression for response of this positional control system is 1 minus 1.125 into e power minus 60 sin 8t plus 0.926 radians. So this is how you need to find the response of the system if the problem is given as a long answer question. Long answer question. Okay. If it is given as a short answer question for 3 marks or 4 marks, maybe you can use this direct formula, and if you know zeta and omega n, you can substitute those values here and get the same expression for the response of the system. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.